Greetings, esteemed viewers of our channel. Today we embark on an exploration of one of the most captivating and thought-provoking topics in modern cosmology, the potential end of the universe through a phenomenon termed the Big Crunch. According to a groundbreaking study published in the Journal of Cosmology and Astrophysics, our universe may not continue its eternal expansion, but could instead undergo a dramatic collapse into a singularity in approximately 20 billion years. In this video, we will dissect this hypothesis thoroughly, drawing upon the latest scientific research and supplementing it with insights from credible sources. Let us proceed systematically to uncover the intricacies of this cosmic narrative. Let us begin with the foundational principles. The universe originated approximately 13.8 billion years ago in the Big Bang, a monumental event where all matter, energy, space, and time emerged from an extraordinarily hot and dense singularity. Since that moment, the universe has been expanding, a process that has accelerated due to a mysterious force known as dark energy. Comprising roughly 68% of the universe's total energy, dark energy exerts an anti-gravitational effect, driving galaxies apart at an increasing rate. For decades, cosmologists assumed dark energy was a constant force, a cosmological constant as introduced by Albert Einstein in his equations of general relativity. This assumption underpinned predictions of a big freeze, or heat death, wherein the universe expands indefinitely. Stars exhaust their fuel, galaxies drift beyond visibility, and the cosmos gradually becomes a cold, desolate void over trillions of years. However, recent observations have introduced a paradigm shift. A pioneering study led by Henry T., an emeritus professor of physics at Cornell University, leverages data from the Dark Energy Spectroscopic Instrument, or DESI, located at the Kitt Peak National Observatory in Arizona. Operational since 2021, DESI is a state-of-the-art tool that maps the spatial distribution of galaxies and precisely measures the universe's expansion rate. In 2025, DESI published findings indicating that dark energy's influence is diminishing over time. Departing from the notion of a positive cosmological constant, Professor T's model suggests it transitions to a negative value, driven by hypothetical particles known as axions, which behave as a dynamic cosmological constant that evolves with the universe's development. Under this model, the universe's expansion will decelerate over the next 11 billion years, reaching its maximum extent when the universe is approximately 25 billion years old. At this critical juncture, the expansion will reverse, initiating a phase of contraction that culminates in a Big Crunch, a reversal of the Big Bang, where the entire universe collapses into a singular point of infinite density. This cataclysmic event is projected to occur when the universe is approximately 33 to 34 billion years old, roughly 20 billion years from the present day. Professor T articulates, the new data suggest the cosmological constant is negative, leading to a Big Crunch. He emphasizes that while the concept of a negative constant is not novel, this model provides a precise timeline and mechanism for the collapse, marking a significant advancement in cosmological theory. This hypothesis does not stand alone. Research conducted between 2023 and 2025, as reported in outlets such as The Guardian and Live Science, corroborates the possibility that dark energy is weakening, setting the stage for a reverse Big Bang. For example, a March 2025 article in The Guardian quotes cosmologists who assert that these findings could fundamentally reshape our understanding of the universe's ultimate fate. Similarly, a July 2025 report in the New York Post references studies suggesting the universe will halt its expansion and contract back to its initial density. Certain theoretical models even propose a cyclical cosmology, where the Big Crunch is followed by a Big Bounce, potentially giving rise to a new universe as hypothesized in quantum gravity frameworks by physicists like Peter Korava or Sir Roger Penrose. However, T's model focuses on a terminal collapse, offering no definitive assurance of cosmic rebirth. To contextualize this scenario, let us compare it with alternative fates of the universe. In the Big Rip hypothesis, if dark energy intensifies as phantom energy, the accelerating expansion would tear apart galaxies, stars, planets, and even atomic structures within 20 to 30 billion years, ultimately disrupting space-time itself. Conversely, the heat death scenario envisions a universe that thins out. In 100 billion years, distant galaxies vanish beyond the observable horizon. In 1 trillion years, the last stars fade, and by 10 to the 65 years, black holes evaporate through Hawking radiation, as detailed in a May 2025 Unilad Tech article. The Big Crunch, however, presents a more dramatic conclusion. Temperatures and densities escalate exponentially, merging all matter and energy into a singular, infinitely dense point, reminiscent of a black hole's core. What are the broader implications of this hypothesis? On a human timescale, these events are inconsequential. Earth will be engulfed approximately 5 billion years from now when the Sun evolves into a red giant, long before cosmic collapse. Scientifically, however, the implications are profound. Ongoing and future observations from DESI, as well as missions like the European Space Agency's Euclid, could validate or refute this model, potentially necessitating a re-evaluation of the fundamental principles governing cosmology and physics. Esteemed viewers, this topic illuminates both the fragility and the awe-inspiring grandeur of our universe. If you wish to delve deeper into the mysteries of the cosmos, we invite you to subscribe to our channel, like this video, and share your perspectives in the comments below. Do you believe the Big Crunch is the ultimate fate of our universe? Until our next exploration, stay inspired by the wonders of the cosmos.